Willst du die ersten Worte sagen, oder soll ich die sagen? Okay. Benjamin, was it you suggesting the word Voto? Okay. So I think we can start. Welcome to our presentation for Voto, a new project proposal. Our presentation, that's Olaf Weimann and me, Stefan Färber. I'm just presenting the first 3 slides and Olaf is taking you to the technology. Voto is a word from Esperanto. It's the English equivalent is word, or the German is Wort. And you see it's very similar. You see maybe later why this is appropriate name, because the name we proposed at Bosch was typical engineering name. It was information models for Internet of Things and services, was this right? And we did an acronym out of that. So the first lessons we learned with Eclipse is make it ease of use, and thanks for the help in that. I'll just have some slides to introduce Bosch. You might know Bosch as a company being responsible for the dishwasher or the power tools in your home. Yeah, we are proud of that, but actually most of our business goes into cars. So under the hood, there's a lot of Bosch inside. We are strong industrial technology, maybe Bosch Rexroth is something you heard. Energy and building technology is an important topic regarding security systems, heating systems, and the consumer goods you know pretty well. We are a strong engineering cultured company with more than 40,000 engineers and more than 12,000 software engineers. And a lot of software we have in our company is built on open source technology. There's some people here from automotive. We are part of the automotive Eclipse group. The next generation of automotive tools will be purely based on Eclipse in the automotive business. I come from Bosch Software Innovation. Some of our tools are also built on Eclipse technology, like Visual Rules, for example. So we heavily depend on this community, and we are proud to be part of this community. And now it's the first time we propose a new project to the Eclipse. So we're also contributing actively for the future of that community. Why is that? Bosch decided in 2008 to invest in Internet of Things, so pretty early. Investment meant that we started a company. It's called Bosch Software Innovations. It's built up with the 2 acquisitions, Innovation Software Technology and Innobit, now belonging to that organization. We are around 500 people. And we are building technology for Internet of Things projects. So in this context, we like to contribute to the Eclipse Foundation. We have topics and projects running in the energy of smart energy topics, smart mobility, connected industry, and smart home. And we like to build this on a platform. As Bosch is in multiple markets responsible for services and things, we'd like to have a platform that cross-cuts these markets also. And I think this is the most important slide for my presentation right now, is why do we think this has to be an open platform? We striving for services and connected products in the Internet of Things market. So this is something new for Bosch in multiple verticals. Internet has been proven to cross-cut verticals. Just remember Amazon selling books in the beginning. Now you can buy everything. Every successful internet player started in one vertical and was scaling out to others. We believe this will happen here also. We have a lot of devices. We produce nearly 1 million pieces per day. If they are all connected, that means they have to be interconnected and interoperable everywhere. And in our strategic analysis, we see that in the end, there will be a few platforms in the market serving Internet of Things. You see this platform business also in the past with operating system or smartphone ecosystems running around. And we believe that at least one of them will be open source, maybe even more. And our bet is that we build our technology on this open source platform. And the reason is very simple. We don't want to be dependent on a single player on the market. And the other way around, also our customers would not like to be dependent on us. Yeah, and that's why we are investing in open technology. And one example of that is then the project Olaf is presenting. Let's do this.
Yeah. Okay. Okay. So thank you. Also welcome from my side. Louder? Okay. Okay. So I try to talk a little bit louder. So I want to give you some background information to our project proposal for Vorto. And first of all, I would like to motivate the project itself. And here are 4 scenarios that we would like to address with that Vorto project. The first one is the consumer perspective. And if we think about what the consumer wants, we believe that the consumer wants to integrate various devices into his IoT system at home or in general into his IoT system. He wants not be bounded to one specific device vendor. And so he wants to be very flexible. If we look at vendors of IoT devices, they want to have their devices integrated on as much platforms as possible, because so they can increase their sales. So the next one is the vendors of IoT devices. They also want a vendor of IoT platforms. Sorry, they want to integrate as much as devices as possible on their platform, because then they have the ability to become some kind of standard. And if it is a commercial platform, they also can increase their sales. And if we go to the application developers, they want to have platforms that support as much as devices as possible, because they want to make their applications possible to use as much as devices as possible. So, and now I think with the Vorto project, we can address all these 4 scenarios. But first of all, let me show you this slide here, addressing only scenario 3 and 4. And let me first say something to the semantics of this slide here. You can see these 3 colored bubbles, and the left one, the KiwiCon bubble, represents all devices that can be integrated on KiwiCon. The Bosch M2M bubble here represents all devices that can be integrated on the Bosch M2M platform. So, for example, device 5 cannot be integrated any of these examples. Device 3 runs on KiwiCon, not on Bosch and ThingWorx. Device 2 can be integrated on all of these platforms, and so on. But now what does a platform vendor want? He wants to be able to integrate all these devices. So he wants to extend his bubble to that red circle around that. That is just an example. I just took Bosch M2M, but the same is true for KiwiCon, and the same is also true for ThingWorx. So how could we now solve this problem here to fulfill the requirements of all 3 of them? Yeah, this is, if we go to do that, then all 3 platforms would be satisfied. It's clear that these 3 are only examples that I took here, and that there exist many more platforms. So I mean the intersection of all these platforms. So now, before I show you the Vorto approach, I want to introduce that information model. And the information model is that's one of the central components of our project. So if we have on the left-hand side a real object, let's say we have a Samsung TV or a Bosch camera, then we need to represent this one in the abstract IT world somehow. And we do this using these information models. On the right-hand side, you can see an information model for the display and also an information model for that camera. So this is the abstract IT world on the right-hand side. So if we go into a little bit more detail, and let's say, okay, our TV has 4 components. It has a tuner, it has a display, speakers and motion detector. Then we would represent this in our information model context as 4 function blocks. 1 function block for a tuner, 1 for display, 1 for speaker, and the last one for that motion detector, and also some device-specific information that may be related only to that specific TV series. So now I did not describe any details about the information model, but I think the most important part now is to understand, okay, that is that abstract IT world, the representation in the IT world. And now I would like to show you the approach of Vorto. If we go back to our bubbles here, then and we assume that, I think we had 5 devices on the slide before, and if we assume we have an information model for all of these devices, so 1 for the first device, 1 for the second, and so on, and all these information models are conformed to a specific meta model. So this is written there above. So they are instances of that meta model. Then they have all the same structure describing their devices. So, and if we also assume we would have some code generators, 1 for the Kivicon platform here, 1 for the Bosch platform, and 1 for the ThingWorx platform, and these code generators use information models to create representations for that specific platforms, then we could integrate a device on the Kivicon, on Bosch M2M, and ThingWorx. So at this now it's clear that if, I don't know, if device 1 is a C-wave smoke detector, for example, then we need some infrastructure and some drivers for that C-wave protocol that this code generator is able to generate on top of this. That's clear, but the configuration of that device itself can be done using the code generator. And what do we have then in the end? This one here. The devices move into that intersection and can be integrated into all of these platforms. And so the consumers are happy because whatever platform they have, they can use the devices, provided that there exist information models and provided there exist code generators. And also the platform vendors are happy because if they have a code generator, all the devices can be integrated into their platform. The application developers are also happy because these platforms become more and more flexible. So we can address all of these scenarios that we had before, and that is what Vorto does. And now let me give you an overview about the project itself. So the Vorto project consists of 4 components. One of the most important ones is that information meta model here. The information meta model describes how information models describe devices. So it structures this information models. The code generators, as I described before, can generate these drivers, these representations for the specific platforms or ecosystems. And the IoT toolset now, that I didn't mention this before, the IoT toolset now allows to create information models that are conform to that meta model. So because if we have such a meta model, an abstract meta model that describes how information models should look like, then it's not easy to create information models based on that information. So we say, okay, we also provide a toolset that allows to comfortably do this. Then it's easily possible to create these information models. So, and on the right-hand side, as we believe that it's not necessary to create these information models more than one time, we want to use that repository to share information models. The repository shall be hosted by Eclipse, and then it shall be possible to check information models in, provide them, and also to manage them. And for developers, it's also possible clearly to download information models, use them directly, or use them as a starting point for creating their own information model if needed. So it's clear that we also need some kind of governance that it makes sure that there can be checked in whatever people want. So it must be some kind of structure. There must be a high quality of data. I will come back to this later. Now let's go a little bit into the components. The meta model here is designed based on the EMF framework. since the EMF framework provides a lot of functionality related to that situation, that we have a meta model, that we have instances of this meta model, and so on. So again, this display is an instance of this specific meta information model, and also the camera information model. Okay, let's go to the toolset. Currently, the toolset has only one component, but in scope is another one. Here you just see, okay, display and camera are both models that have been created using that toolset. Now let's go to that detail slide. Here, what we did is we created a DSL editor based on Eclipse that allows to comfortably write down these information models in that DSL. And yeah, you have some features like auto-completion, syntax highlighting, features that you would expect when you have a DSL editor. And we also plan, this is the box below here, we also plan to implement a graphical environment, since that DSL approach is very interesting for people that have an IT background, that are familiar with scripting languages and so on. But business people might also be interested in creating information models, but have not that IT background. So they could use that graphical environment then to do that. It's also clear that we need to have some integration with that repository, because in that IoT toolset you can write information models. You should be able to check them into the repository, but you also should be able to download information models from the repository to use them, to browse the repository and all of that stuff. That is that integration and connection to the information model repository part. Okay, now next component, code generators. I've just written down here 2 examples. If we now have an information model, we want to use it for creating a representation. For example, one code generator could be an XML representation generator, or another one creates a skeleton for OSGI DAL. This is all possible because the only requirement that we have for that code generator is that it implements that code generator interface. So there is everything possible. The code generator just uses the information model and the meta model to create something. What that is, that's not clear. Here are 2 examples. I will also show you an example later for OpenHub. And I think there is a lot of potential what can be created out of these information models. So the last component, the repository here. I've indicated here above that we need some kind of governance. There's also a part that we are currently discussing how to establish something like this. And the repository itself is also not realized. We're also in a specification phase discussing what would be the best technology and how we should realize this one. Okay, and as I said, information model repository for managing, sharing, providing information models. So now all the components at one glance. The repository, the IoT toolset connected to the repository on the right-hand side, a few code generators, for example, OSGI. I don't know, 1M to M HGI would also be something where we could support. Above there, the governance above the repository, and down there also an interesting part that I did not mention before, an import mechanism. So we know that there are several standards available. I don't know, ETSI, 1M to M, and there are IPSO smart objects. There are a lot of models available now, and there are also a lot of descriptions of devices based on these models. So we think it makes sense to also have import mechanisms to import existing information models and to create then, using the code generators, other representations out of that. So, okay. Now let me show you a use case how we could use that stuff now. If we look at OpenHub, then we could have the situation that a vendor creates a new, I don't know, for example, a C-wave smoke detector, and somebody wants to integrate this one on his OpenHub environment. Then, for example, an OpenHub community member could browse the repository, find a related information model if this already exists, and downloads this one. If he has now an OpenHub code generator, he would just use that information model to generate the items, maybe also sitemaps, whatever that code generator supports. And you would have your eyes on the OpenHub side. You would have the items, and so on. And then you could use that smoke detector in the OpenHub environment without knowing anything about the device. So that is the process. And now some pictures how this could look like in a UI. First of all, let's say, okay, we have such a tab where we could configure that OpenHub code generator, could do some configurations. Then we would say, okay, now we go to that browser tab and search for smoke detector here. Then we would find, for example, here, 2 smoke detector function blocks, one with version 1.0, one with version 1.1, describing in general functionalities of a smoke detector, and 2 information models, maybe one for Bosch, maybe one for Fibero. And so now I know, okay, my smoke detector is, for example, this Fibero one here. And so I download the information model into my Eclipse environment, and then I would have it here. So I would have here Fibero 22, consisting of 2 function blocks, one for smoke detector and one for temperature sensor, since some of these smoke detector also have temperature sensor functionalities. So, and on the right-hand side, you can see that information model just grouping 2 function blocks, smoke detector and temperature sensor. And now I would say, okay, I select this one and say now generate OpenHub. And now I would get my items and my sitemap, for example. And this could be integrated into OpenHub, and then I can use that smoke detector. That is just an example. So that is, I will come back to this in a short live demo now. But first, I would like to give you an overview about some technical aspects. Okay, that meta information model is based on EMF. We use the capabilities of that framework, and also use it for validations and so on. The IoT toolset here provides currently that DSL editor, and the grammar of that DSL editor corresponds to the meta model. So, and this one is based on Xtext. Then the code generators, there are no requirements. It is just an interface that exists now that has to be implemented, an extension point of the IoT toolset, and there you can put new code generators into. So that were the slides that I wanted to show you. Now let's have a look into that Eclipse. So what I have here, that is that DSL. So you see, you cannot see everything here. Now it's a little bit better. So on the left-hand side, you see 2 function blocks that I have in the editor right now. You can see here, for example, that smoke detector. The grammar of the DSL looks like this one, the DSL itself. And what I did, I wrote down a very short, very simple example of a smoke detector. For example, for the configuration part, you could specify a sensitivity and an alarm type. For example, the alarm type here could be a siren or some LED signal. You can see the data type below there. And there is also a status for that smoke detector, if it is active or not, and a flag if the sensor has identified that something is defect. And below there are some operations. Also, only examples. For example, you can check if the sensor is active. You can toggle that status, get the sensitivity, set the sensitivity, and so on. So what we did now, we created a small example code generator that allows to generate a small web app displaying now that information model. So what we would do is we would go here on that smoke detector, I switch to the Java perspective, because then you can see that a new project that will be created. Then we would go to M2M and now say generate code, and then we would say here device web application generator. Now you see it does some generation stuff, and now this is a Maven project here, and first of all let me update this one. Okay, so and now let's run this. I would say run as Maven build. Hopefully there's not running another instance in the background. No, it isn't. So and now we could display that information model here. And here you can see it. We saw that is active flag, that sensitivity, an alarm type, that defect flag, and here below you can see the operations. So what has been generated is the following. Let's go here. There's just a simple Java class that has been generated out using that code generator. And this shall only be a small example which shall show you the approach. As well as this web app, we can also create a representation for our Bosch M2M. There we would use here, again, that generate code, would choose here Bosch M2M generator, and then we will get 2 other Maven projects. We would also need to press that update button and so on. And but let me show a small thing of this one. So here we have some classes, some XMLs. That is all of that stuff that the Bosch M2M needs to integrate a device. Okay, that is what I wanted to show you today. Are there any questions? Yeah.
Yes, about your meta model. So
yeah.
I assume that eCore is supposed to support all kinds of devices.
Mm-hmm.
So what's your plan for making sure you can support all these different kinds and categories of devices? Because I would assume there's not a single person on the planet that can list all of them.
Yeah, what we do is we have a meta model in our current M2M solution, and we will use this as a starting point and then hope for a lot of input from the community to work on this meta model and make it flexible. But however, we believe that the model itself should be let's say some kind of simple, because a very complex model requires experienced specialists to use it. But a simple one containing most of the functionalities that are needed would address a large community of people. So I think our model will be a starting point. It is an easy model. It has a lot of capabilities, but it is easy and it will be a starting point. However, we believe it will not be the solution in the end. Yes?
It's a follow-up. What is the scope of this model? Is it user devices, also a home user, or is it industry devices also?
No, it's very generic.
Everything.
So, yeah, we would like to represent everything, and this is done using that function block concept, where we say, okay, a device has some attributes, and it has some functions, and this is represented using that function blocks. We also may have some validations that we want to integrate in this one. That is another part, but it's very generic. There's no specific domain what we would like to address. Yeah.
Will there be different kinds of predefined function blocks? So I'm wondering if, for example, 2 companies will represent their device in this model. Will there be common semantic, for example, a motion detector, or will it somehow be the same?
Yeah, we think about what the process would be, how these function blocks information models come into that repository. So if maybe we'll provide some initial function blocks. Maybe they come from device vendors itself. We are searching partners currently. But just for background for that information models, what we would like to standardize are these function blocks. These are standardized components. The information models group that function blocks, and then are maybe using with these device-specific information, then really specific for such a device. But yeah, I think we need partners to grow that amount of function blocks that are available, and that's currently the plan.
There are already some standardization bodies thinking about defining an initial set of must-have devices or generic devices, like defining a switch or defining a potentiometer, stuff like that. So these are very basic building blocks that you might initially add to that repository so that they can be used by others to build upon. But then again, nobody really knows what these initial building blocks should be, and this is subject to discussion, I think.
Yeah.
We have in ODI, we have a let's say a specification on this for the device abstraction layer where we define also some functions representing light switches or whatever. Very simple starting point also, but HCI is currently working on this as well, and I think there will be a presentation today. Yeah, it's fun as well.
Yeah, so that could be a very good starting point, I think.
Yeah. There was a question.
So who would be responsible for maintaining the code generators? Will it be one, let's say, code generator repository, which is maintained by several vendors? Or, and other question, is it possible to use the code generators outside of the IDE? So is there a headless request plan?
Currently, we plan. Yeah, I think it's possible to use these code generators outside. However, then whatever wants to use the code generators must be aware of that meta model, because this interface is quite relevant. So the other question. Currently, the code generators shall be part of the Warto project, but we are also open to if somebody wants to provide a specific code generator within that specific project. So we are also open.
You can also imagine using something like Eclipse Marketplace for finding
Yeah.
these and downloading into internet. But then in the end, it's an open source project. So you implement your code generator, upload the code to GitHub, and provide a pointer to, well, if you want another code generator, here's one. Go collaborate or use it, whatever. But definitely, I think there should not be a central entity that sits on top of these code generators. It should be a community effort. It should be an open source project, open to everybody. Everybody should contribute. I think the only spot where we really need some governance is this central repository where you put the initial set of information model or function block definitions. Because otherwise you will end up with hundreds of duplicates of basically the same thing.
That could be standardized.
Yeah.
Right, yeah.
Yeah, I think one of the pros with code generators could be there are several versions. So one version is buggy. Person A uses this code generator, person B uses this code generator, and there is a central repository for code generators and some, let's say, entity which says, okay, this is the current version, use this version. Then I think there could be fragmentation, and this could be a problem for that approach.
So I can also imagine that different target ecosystem communities can maintain these. So for example, the Open Hub community can maintain a code generator that is kind of official for the Open Hub community, something like that. Or a vendor can create an official code generator for their platform. Whatever. Anything goes.
Okay.
In your demo, what technology did you use to implement this code generator?
This is based on the Eclipse extent.
Yes, I'm just asking because in your slides you still mentioned expand, and extend have kind of superseded expand by now.
Okay. If there are no.
It is like an open source project. We encourage everyone who who's interested in that to participate, and because that is actually, it's not that Bosch is coming there and saying, this is the solution, use it. It's actually the other way around. It's like have an idea, and we would like to hear from everyone what they think about it and what like is maybe wrong about it or what kind of improvements there are. And it's not only about the code generators or like things like all the info models. It's also about the concept. So who knows where we are like in about a year. IoT is changing a lot, and so we actually want to participate. We want to participate in the Eclipse IoT strategy and like saying, okay, and we are just one of all the other ones, and we would like to have that happen, that there will be a good IoT solution out there that we can use.
Yeah. And also we appreciate any kind of feedback and discussion related to our project to make it successful. Okay. So thanks again.